What's up, guys? How you doing? I want to talk about the implications of the Sundial experiment that I performed in 2020, uh, where I set up two sundials. I think it was over 100 feet away. It was over 100 feet away. They were over 100 feet away. Two sundials, and I used my laser back there to align them so that they're, level and parallel with each other, and so that their parallel orientation is perpendicular to the sun at a particular time of day. So what I did is I left them like that so that they're parallel and a straight line like this with each other. They're on a line with each other. And then midday, it was like around 1:40, I think it was. It would get perpendicular to the boards, and then I go and I make my recording, and I go and see what the angles are, and I make a recording, and then I do a bunch of math and figure out how far away the sun is based on the angles of the shadows on the sundial, on the sundials. And then you get a radius. You make a big circle with those 2 points, because the sundials are 2 points on a big giant circle. They're the the distance between those two sundials makes a segment on a very large circle. I think it was like it was a lot of segments. It was like 9,000. I can't remember what the segment number is. I would have to go in there and look at the paper, but like you set it up like that, and then you get your measurement, and you do the math down to a radius, and you get a radius from the center point between those two sundials to the sun, and you get the radius of that circle that you just made, basically. And you get a very, very thin slice, a 1 degree or a 2 degree wide thin slice of a very big pie, is how I got my measurement. So, and the measurement came up to uh, one time was 1.08 kilometers, and another time was 1.4 kilometers. And then another time, I just looked at it before this video, was 2.4 kilometers, 1.08, 1.4, and then 2.4 kilometers were the distances that I got on the experiments that I just looked at. So I want to talk about the implications of this distance of this, because those first two measurements, the 1.08 and the 1.4, were of the same when the sun is in the south. Was when I did that. And then that third measurement, the 2.4, is when the sun was further along the day. It was almost 6 o'clock. It was getting where I measured it from. I couldn't really see the horizon, so the sun was getting close to the top of the trees, so I had to make my measurement then, because that would be the furthest point away. It getting at the top of the trees, for me to get a shadow at that moment, is the furthest point away that I can measure the sun. And at that point, it was 2.4 kilometers. So that means it went along the day, and It kind of implies it stayed at a similar height. What that mean is what I feel like that might mean. I haven't done the math on that much yet, but like it because it's only a 1 kilometer difference. You know what I mean? It's only a 1 kilometer difference between 1:40 p.m. and 5:40 something p.m. Uh, 4-ish hour difference. Uh, so I want to talk about the implication of these distances. It only being 1 kilometer, 2.5 kilometers away. Uh, so at that almost 6 o'clock timing, it still had it was only 5:40, so this is only just short of 6 o'clock. So like it still had more time to go and more distance to go before it passed over the horizon and was completely out of view, meaning that there's more distance added on to that 2.4 that I got. So since I can't measure past the trees, or couldn't measure past the trees at the time, I just added 1 kilometer, just to be safe, because I feel like adding more than 1 kilometer, there's a chance I'm gonna overestimate, you know what I mean? So all I did was add 1 kilometer to that, so 3.5 kilometers basically to get to the horizon. Which isn't that different from what the internet says. The internet says 3 miles. So, so, so 3.5 kilometers to the horizon, right? And that's in both directions, right? That would be in both directions. So 7 kilometers, right? So 3.5 kilometers that way, 3.5 kilometers that way to each horizon, 7 kilometers, right? And the sun takes 12 hours to travel that 7 kilometers. 12 hours to go from that horizon to that horizon. And then another 12 to go the extra, basically still 40,000 kilometers. The extra 39,000 extra 39,000.9 kilometers. You see what I'm saying here? 12 hours to go 7 versus 12 hours to go 30, nearly 40,000. That's a speed difference, right? That's a speed difference. Something is changing speed. Or if it's not changing speed and there's just magic happening, you know what I mean? So there's that aspect of the measurement. Because I did it multiple times. I'm certain I'm not wrong about this, because I can't look at a shadow wrong, you know what I mean? I used a laser to align the thing. That's light. I used light. That is the straightest line that you can make. So there's that aspect of it being 7 miles versus nearly 40,000, both taking 12 hours to cover, and that's a major that's a major physics problem. That's an issue with the laws of physics right there. because I can't come up with an explanation for that. I have theories, but that's going to be the next video. That may be part 2. So there's that aspect of it. And the fact that it does this, I'm going to go to part 2. Let's go to part 2. Let's just explain this in part 2.